Howdy, this is an introductory video on predicate logic, and primarily it will be an introduction to universal instantiation based on the textbook by Suppes Hill, First Course in Mathematical Logic. I'm the amateur logician. Predicate logic allows us to deal with what is perhaps the most famous argument in all of logic, namely premise 1, all men are mortal, premise 2, Socrates is a man, conclusion, therefore Socrates is mortal. Intuitively, this argument seems valid, and indeed, it is valid. The first premise is a universal proposition about every x. So premise 1, all men are mortal. We have in symbolic notation, for all x, if x is an h, then x is an m, where h stands for men and m stands for mortal. So our first premise, we have a universal proposition about every x. Ergo, if we can specify a specific object, it must be the case that what's true of the universal is true of the specific object. Aristotelian scholastic logic, by the way, would appeal to the dictum de omni et nolo, which means the maximum of all and none. We have a maximum. The first premise is all men are mortal, so it's a maximum. So every particular man must also be mortal. Socrates happens to be a particular man, so therefore Socrates must be mortal. Now, to justify validity, basically what we will do is this. We'll first symbolize, and that's what we did. We will symbolize our argument in first order predicate logic, and then we're going to specify a specific object for x. In this case, that specific object happens to be Socrates. We're also going to remove the quantifiers, and the quantifier here is for all. That is the upside down A. So we're going to remove the quantifiers so as to use the tools of propositional logic. Predicate logic just works on top of propositional logic. Remove the quantifiers, you're basically just back at propositional logic, and you can use the standard rules of inference, such as modus ponens, modus tollens, disjunctive syllogism, etc. Now that we have the general gist of this type of argument, let's get into the details. Our basic proof procedure is as follows. We're to symbolize, we're to specify a specific object, at least in this type of argument, and then we're to use the tools of propositional logic once our quantifiers are gone. So the first thing is to symbolize our first two premises. You have all men are mortal. All means it's a universal affirmative proposition. We need the quantifier for every or for all. We have two terms, men and mortal. Thus we'll say for all x, if x is an h, then x is an m, where h stands for man, m stands for mortal. Premise 2, we have Socrates as a man. We have two terms, Socrates and man. Man is a predicate, so we'll give that a capital H. Socrates is a subject, so we'll give that a lowercase s. In here, we're going to get right into the proof. It's very straightforward. We'll do a so-called universal instantiation of the first premise. So instead of x, we're going to substitute a specific object for x. We're going to substitute S, which stands for Socrates. So we'll say, if Socrates is a man, then Socrates is mortal. Already, with premise 2 and our derived third sentence, we can prove what we want because we can do a modus ponens inference. Premise 2 tells us that HS is the case, so we could affirm this antecedent to then affirm this consequent. So by modus ponens with sentences 2 and 3, we can say that MS is the case. In other words, that Socrates is mortal. The only thing that's new here is really the universal instantiation. Now the textbook by Suppes Hill calls it universal specification, but I'll try to stick with more conventional terminology that you find in most standard textbooks. Let's pause and recall that, on the one hand, we have so-called reserved variables. These would be x, y, and z. These variables don't stand for or represent any particular thing. They don't stand for any specific object. Rather, they are general. They are, so to speak, vague. Hence we say for every x, or for all x, where x can stand for anything whatsoever. On the other hand, all other letters are for particulars. In other words, they are constants, or perhaps better put, they name a specific thing. Hence, in the last example, we used the letter S to represent Socrates. And Socrates, obviously, is a specific thing. Socrates is a specific person. Now, with universal instantiation, it turns out we can instantiate both particulars and variables. Let's consider the general form for all x, x is an f. And let's pretend that this stands for everything is material. Now, given that sentence, by universal instantiation, it would follow that, therefore, Socrates is an F, or Socrates is material. And here, of course, our universal instantiation is of a particular thing or particular person. Since everything is material, obviously, because Socrates is a something, he must be material, because everything is material. And likewise, from everything is material, we can say y is material, where y obviously represents a reserved variable. Y is general. It's not specifying a particular thing. But because everything is material, it must be the case that y, which can specify anything, is also material. Thus, with universal instantiation, again, we can do both particulars and variables. It's a good time to jump right into some exercises. On page 214 of the Suppes Hill textbook, number 11, we have the following argument. All congressmen are either senators or members of the House of Representatives. Mr. Anderson works in Washington, but he is not a member of the House of Representatives. Therefore, if Mr. Anderson is a congressman, he is a senator. Makes sense. All right. First premise, we have a universal affirmative. And notice we also have a disjunction because we have this either, this or. So in the consequent, we will have a disjunction. So premise 1, we have for all x, if x is a congressman, then x is a senator, or x is a member of the House of Representatives. So C for congressman, S for senator, R for member of the House of Representatives. Okay. Premise 2, Mr. Anderson works in Washington, but he is not a member of the House of Representatives. There's a conjunction there. The but is really an and. Works in Washington is the predicate. Mr. Anderson is the subject. So we'll give that a capital W, lowercase a. We have the and sentential connective. He is not a member of the House of Representatives, so not R A. Conclusion, we have a conditional. If Mr. Anderson is a congressman, he is a senator. So we'll say capital C, lowercase a, arrow, capital S, lowercase a. If Mr. Anderson is a congressman, then Mr. Anderson is a senator. Now, given that our conclusion is a conditional, it looks like we're going to do a conditional proof. But before then, let's instantiate our first premise, our major premise. So we have for all x, such and such. It's universal in scope, so we can substitute something, anything, into x. What do we substitute? Well, of course, Mr. Anderson, which is represented with the letter A. So for line 3, we can say CA implies SA or RA by universal instantiation of line 1. In other words, if Mr. Anderson is a congressman, then Mr. Anderson is a senator, or Mr. Anderson is a member of the House of Representatives. Okay. So now I think is a good time to actually make an assumption. So we'll assume the antecedent to that conclusion we want to prove. So for line 4, we'll just say CA by assumption. And because it's an assumption, we'll place it under quarantine. But based on that assumption, we could affirm the antecedent on line 3 to get that consequent, but also under quarantine, of course. So for line 5, we can get SA or RA by modus ponens with lines 3 and 4. We have a disjunction, SA or RA. Line 2, we have this not RA in a conjunction. And because some textbooks only allow us to simplify the first term, I'm just going to follow that convention. The Suppes Hill textbook allows us to simplify either term right away, but at any rate, we'll say not RA and WA by the commutative rule, line 2. And then for 7, we'll simplify to get not RA, line 6 under quarantine. But notice this contradicts RA there in a disjunction, so we have SA or RA, not RA, therefore SA. So for 8, we can say SA by our disjunctive syllogism, lines 5 and 7. And based on our assumption on line 4, we're able to derive SA. And so outside of quarantine, it does follow that if CA, then SA by our conditional proof with lines 4 through 8. In other words, it is the case that if Mr. Anderson is a congressman, he is a senator. It's always a good idea to pause the video and try some of these problems yourself. This is exercise 4 on page 222, argument number 4. Every pupil who has done his homework understands the problem. Ernie is a pupil, but he doesn't understand the problem. Therefore, Ernie hasn't done his homework. First premise, we have a universal affirmative proposition. We have pupil, the subject, but along with that we have someone who has done his homework, so that will be in the antecedent, and the consequent we have understands the problem. So the first premise is for all x, if x is a pupil and x has done his homework, then x understands the problem. Premise 2, Ernie is a pupil, but he doesn't understand the problem. We have a conjunction. Line 2, we have pupil as the predicate, Ernie as our subject. We have the and sentential connective. He doesn't understand the problem, so not UE. And then from those two premises, we have the conclusion that Ernie hasn't done his homework, so not HE. First thing we should do is to remove our quantifier. So we'll instantiate premise 1. What do we substitute in for x? Well, obviously Ernie. So for line 3, we'll say PE and HE implies UE, universal instantiation, line 1. If Ernie is a pupil and Ernie has done his homework, then Ernie understands the problem. But notice line 2, apparently he doesn't understand the problem. So let's, for line 4, I'm just going to simplify right away. Some textbooks do not allow this, but Suppes Hill do allow this. So we'll say not UE, simplification, line 2. So this contradicts the consequent of a conditional, so thereby we can deny the antecedent, because the consequent is always necessary for the antecedent. So we'll say not, parentheses, PE and HE. By modus tollens, lines 3 and 4, we have this negation side, and we have a conjunction. So let's apply De Morgan. Line 6, not PE or not HE. De Morgan, line 5. Line 2, we have this PE. That contradicts this not PE, so let's simplify. So for line 7, we can get PE by the simplification of line 2. Let's double negate. So for 8, we'll say not PE. Double negation, line 7. So this not PE denies this. And so for 9, we can say therefore not HE, because we have a disjunctive syllogism with lines 6 and 8. And so Ernie hasn't done his homework. Let's give number 5 a shot. First premise, everyone who was a composer of the 1812 overture deserved an early grave. Don't blame me, by the way. This comes from the Suppes Hill textbook, so all that matters is I'm off the hook. But anyways, how would we translate this into our predicate logic? We do have a universal affirmative proposition, so we'll say for all x, if x is a C, composer of the 1812 overture, then x is a D, deserves an early grave. Scarlatti wrote for the harpsichord. That's premise 2, so we have capital H, lowercase s. Premise 3, no one is both a true musician and deserves an early grave. We have a conjunction there. It's a universal negative proposition. So for 3, we have for all x. It's not the case that x is a true musician and x deserves an early grave. 4, all who wrote for the harpsichord were true musicians. Universal affirmative proposition. So for all x, if x is an H, then x is a T. Therefore, Scarlatti was not the composer of the 1812 overture. So we have conclusion. Therefore, it's not the case that C, S. We're going to have to do some universal instantiations. We have line 1. We have line 4. That's a good one to instantiate because we have this HS there, and then we can do some modus ponens inference eventually. So let's first just instantiate the line 1. So for 5, we can get CS arrow DS by universal instantiation of line 1. And then for 6, let's instantiate like 4, so we get HS arrow TS universal instantiation 4. And notice, of course, line 2, we have HS, so we can do a modus ponens inference. For 7, we can get TS, modus ponens, 2, 6. Now we can instantiate line 3. So for 8, we can get not parentheses, TS and DS, universal instantiation, line 3. Let's apply De Morgan. So for 9, we can get not TS or not DS, De Morgan 8. Let's see. Well, notice line 7, we have TS, that contradicts not TS. Let's double negate. For 10, we can get not TS, double negation 7. So that's not the case, so that must be the case by our disjunctive syllogism. 11, not DS, disjunctive syllogism. 9, 10. And now notice we have this not DS that appears as the consequent, the contradictory of it. And so because the consequent is necessary for the antecedent, we can deny that antecedent. So for 12, therefore it follows not CS by modus tollens with lines 5 and 11. Argument number 3, we have a number is even if and only if it is divisible by 2. Premise 1, for all x, x is an even number if and only if x is divisible by 2. 3 times 5 is not even, but 3 plus 5 is divisible by 2. Second premise, we have not E 3 times 5 and D 3 plus 5, where E is a predicate even number, D is a predicate divisible by 2. Conclusion, therefore, 3 times 5 is not divisible by 2, so not D 3 times 5, but, or in other words, and 3 plus 5 is even, so and E 3 plus 5. We'll do universal instantiation with 3 times 5. So for line 3, we'll get E, and we're substituting 3 times 5 into that x, so E 3 times 5, if and only if D 3 times 5 by the universal instantiation of sentence 1. for 4, I'm going to use a commutative rule. In this case, we'll say D 3 times 5, if and only if E 3 times 5 and then by the biconditional law we can get D 3 times 5 arrow E 3 times 5 biconditional law sentence 4. We can simplify from line 2, so for 6 we can get not E 3 times 5. So this is a simplification of 2. And now we have a modus tollens inference we can make. So for 7, we can get not D 3 times 5. Modus tollens 5, 6. Now we'll work with 3 plus 5. We'll do a universal instantiation. So for 8, we can get E 3 plus 5 if and only if D 3 plus 5 universal instantiation sentence 1. For 9, we'll do the commutative rule because I want to, and some textbooks in fact require it. So I'll say D 3 plus 5 if and only if E 3 plus 5. Commutative rule 8. For sentence 10, D 3 plus 5 arrow E 3 plus 5 biconditional law sentence 9. We'll use a commutative rule on sentence 2. So for 11, we'll get D 3 plus 5 and not E 3 times 5. Commutative rule sentence 2. 12 will now get D 3 plus 5 by the simplification of 11. Now we can do a modus ponens inference because we have this D 3 plus 5. So for 13, we'll say E 3 plus 5 modus ponens 10, 12. On sentence 8, we have this not D 3 times 5, and for 13 we have E 3 plus 5, so we'll combine them together. For 14, we'll say not D 3 times 5 and E 3 plus 5 by the conjunction rule, sentences 7 and 13. Number 12 will be our last argument. It's from exercise 3. We're told that no triangle congruent to ABC is equilateral, that only triangles congruent to ABC are congruent to DEF, that triangle GHI is equilateral, and that therefore triangle GHI is not congruent to DEF. This one's a little bit tricky in terms of how we symbolize it, especially for the second premise. The first premise is straightforward, so we'll say for all x, if x is a triangle congruent to ABC, then it is not the case that x is equilateral. But the second premise, we have only triangles congruent to ABC are congruent to DEF. This only implies an exclusivity. Moreover, if it's the case that you have triangles congruent to ABC are congruent to DEF, it must also be the case that a triangle congruent to DEF must be congruent to ABC. Okay. And you can think about this materially in the sense of the actual content of what it's saying. So let's say we have this triangle here, A, B, C, and if that's congruent with this triangle here, D, E, F, I know these are horribly drawn. If there is a congruency, it goes both ways, right? So it's really a biconditional here. So we'll say for premise 2, for all x, Tx, if and only if dx. Okay. T, of course, represents triangles congruent to ABC. D represents congruent to DEF. And for our third premise, we have triangle GHI is equilateral. So we'll say EG. Conclusion, therefore triangle GHI is not congruent to DEF. So we'll say not DG. All right. For our fourth sentence, we'll get TG arrow not EG by the universal instantiation, line 1. For 5, let's do some double negation. We have EG on line 3, so we'll say not EG by the double negation of line 3. For 6, we can get not TG by modus tollens, lines 4 and 5. For 7, we can get TG if and only if DG by universal instantiation, line 2. For 8, let's do the commutative rule. So I'll say DG if and only if TG. This is from line 7. For line 9, we can get DG arrow TG by the biconditional law, line 8. And then we have what we need. We can do a modus tollens inference. So for 10, we'll say therefore not DG by modus tollens, lines 6 and 9. I want to reiterate the major limitations of the Suppes Hill textbook before I conclude this video. Now, in regards to predicate logic, the Suppes Hill textbook basically sticks with universals. It doesn't deal with existential quantifiers. In this series of videos, however, I will go further than the textbook. In general, as I've noted before, predicate logic works on top of propositional logic. So, predicate logic must introduce tools to either add or remove quantifiers, and those quantifiers can be universal or existential. If we're adding quantifiers, we're dealing with generalizations. If we're removing quantifiers, we're dealing with instantiations. In this video, we dealt with universal instantiation. Predicate logic must also introduce tools for us to recognize equivalencies. You can have equivalencies between sentences with quantifiers. Now, in the next short videos, we'll fix the major limitation of our textbook. I will introduce the other types of rules of inference. Well, up next will be a so-called bonus video. It'll be on universal generalization, in addition to universal instantiation, as we continue our lessons in predicate logic. It'll be a relatively short video, 20 minutes at most, so that's up next. Thank you so much for watching.